We have another examples on the board. This time I have to find value of x. What I have to do first? I'm going to apply the logarithm to the both sides of the equation, and I'm going to have log x to power 2.5 is equal log 14. Next, I'm supposed to use the property for the log of power and bring this exponent to the front of the logarithm. And I'm going to have 2.5 log x is equal log 14. Next, I have to make sure that the logarithm with x is going to be by itself on the left side of my equal sign. That's why I have to divide both sides equation by whatever is multiplied to log. I have to divide by the coefficient, 2.5. And 2.5 will cancel out, and I have log x is equal log 14 over 2.5. Next, we're supposed to use the definition of the logarithm to find value of x. Keep in mind that this logarithm has invisible base 10. So I have to write 10 to power log 14 over 2.5 is equal x. If you are going to plug in these numbers into the calculator, you're supposed to get the value x equals 2.8736. This is the solution to this problem. If you want to verify the answer, simply replace this x by this value, and you're supposed to see that the left side is approximately equal to the right side. Let's take a look at the second example. Again, I'm supposed to apply the logarithm to both sides of the equation. You can apply the common log, or you can apply the natural log. Why? Because this base is different than 10 and different than e. So let's practice natural log. So I have ln x 2.56 equals ln 12.48. You're supposed to apply the property for the log of power and bring this exponent and let it be coefficient. So I have 2.56 ln x equals ln 12.48. In order to find the value of x, I have to divide both sides equation by the coefficient of your logarithm. So you have 2.56 in the denominator and divide by 2.56. They are going to cancel out, and you are going to have natural log of x equals ln 12.48 over 2.56. Keep in mind that natural log has base e. There is always invisible base e. So you have to use the definition of the logarithm and simply convert the logarithmic form to the exponential and write e to the exponent natural log 12.48 divided by 2.56. This is equal x. So value of your x must be equal 2.6804. If you want to verify your answer, simply replace this x by this value raised to the power 2.56, and you're supposed to get the value approximately equal to 12.48. This is the solution to this problem.